Right. Can you all see? Yeah. Okay, so last chapter we just finished ordinary differential equations. So we're going to start a new chapter now. The chapter is called Numerical Method. So basically, the chapter is all about looking at techniques to solving equations. Numerical techniques. In other words, we're going to show you, or you're going to look at techniques to solve equations, but you won't get the exact answer. You'll just get a very close answer, which is often good enough for some problems. Okay, so there's two main techniques. So one class for each technique. So in the first class, we're going to look at what's called the Newton-Raphson technique of solving an equation. So firstly, when do we need to use this technique? Well, consider the problem of finding the root of f of x. That is, consider the problem of solving this equation. I mean, we've looked at finding roots from the beginning. We know how to find the root if it's linear, and we know how to find the root if it's quadratic. What can we do if it's quadratic? Well, we have the formula, we have stuff like this. Cubic starts to get a little bit more difficult. What do we do if it's cubic? What do we do if it's cubic? Yeah, well, what's one way?
Oh, long division.
Long division. But what do you need for the long division technique? You need to already have one root. And this often can be a problem if you don't know any of the roots. Now, if you don't know any of the roots, how can you find one of the roots? Well, you can guess. And what way do we guess? Well, we try 0, 1, 2, 3. What's the problem with this? Well, it takes a long time. What else? Could be 59, yeah. What's another problem? What's a very big problem with this? Well, a very big problem is I'm assuming that the root is a whole number. The root could be 1.5. And then we've completely missed it when we've jumped to 2. So it's not a great technique to solve in cubic. It works only if one of the roots is a whole number and the whole number is quite small. Okay? So we need to find a better way to find one of the roots. And the technique's going to be Newton-Raphson. Okay, so I think I'll show you the idea of Newton-Raphson actually with a graph. Where's my paint program? Don't I have? Okay. So excuse me while I just install a paint program here. Yeah, there we go. Okay, well, while that's doing there, I'll say a little bit more about Newton-Raphson. Newton-Raphson is used for finding roots. For example, in semester 1, we used a guessing method to find the roots of the cubic. This isn't a great way to find the roots, and it doesn't always work. Okay. Perfect. All done. There we go. So this is just a graph I'm going to show you to explain the idea behind Newton-Raphson technique. So let me just get it into the screenshot here. Okay. Right, you can all see that? So let me draw my graph here. Yes, it's beautiful, I know. Okay, put my x here, put my y here. Let's draw a type of cubic graph. Oh yeah. Roughly cubic, okay? Right, now so this is the idea of Newton-Raphson. What points are we looking for? We're looking for the roots. How many roots are there here? 3. Now in the example of the cubic, often if we find one root, we can use long division to find the other 2. Newton-Raphson will give us one of the roots, or usually gives us one of the roots. And this is the idea. Suppose, for example, let's say this here is 1 and this here is 3 as the 2 roots. And let's say this is -3, something like this. -3, 1 and 3, maybe. So let me just put those there. So let's say this one here is at -3, this one here is at 1, and then this one here is at 3. Now suppose I was to guess, let's say, okay, I think the root could be 4. Whoops. So let's get it here. I think the root, maybe the root's something like 4. Oh, jeepers. Now, is the root 4? No, the root's not 4. So if I was to try 4 and I put 4 into the function, will the function be 0? No, it won't be 0. What would it be? Let me just continue this on a bit. Oh, it's beautiful. Okay, so there's x. And here, this here, f4. Font is too big. There. Now, is this height here 0? It's not, okay? If I was to put 4 into the function, I don't get 0. Why don't I get 0? Well, it's not a root. If I was to put 3 into the function, what would the answer be? 0. So this here, this height here is f of 4. You know, if you put 4 in, you find the y value, which is the height, okay? And you want this height to be 0. It means you got the root. So in some sense, this is how wrong we are. The bigger this is, the more it's not a root, okay? And you might say, well, I try 4. What would be a good guess of what the next root could be? Now, in semester 1, we would say, okay, we try 4, maybe we try 5, or maybe we try 3, okay? But we want a precise way to know what would be a better guess. And the idea for Newton-Raphson is this. What you do is, you take your first guess, and you look at what you get. If you get a root, you're done. If you don't get a root, what you do is you draw a tangent line. Okay? Oops. Let's pretend that's a tangent line. So I draw a tangent line, and what I do next is I look at where the tangent crosses the x-axis. So the tangent crosses the x-axis right about here. Now, look at what's happened. I found the tangent line, I drew the tangent line to the x-axis, and look at the solution, or the value I got. You see how it's very close to the actual root. So in other words, the key idea of Newton-Raphson is, you make a guess, your guess is wrong, but that's okay. You draw a tangent line from your first guess, see where it crosses the x-axis, and this actually gives you a better guess. And then if you draw another tangent line, now I'll have to zoom in here. How do I zoom? Okay. So there's my second guess. Now, let's look at what the second guess does. So I put in, what do we say? This is like 2.9. F of 2.9, will it be 0? No. What will it be? It'll be a negative number because look, it goes down. See? So that's f of 2.9. But if I draw another tangent line here, look carefully. Here's my next tangent line. Oops. There we go. Look what's happened. See, there it is there. Okay, and then if I draw another tangent line, it gets closer again. So I'll try to draw one more tangent line. So I try f of 3.1, so I'll do it in red here so you can see it. And I draw another tangent line, and look what's happened. It's gotten even closer. Okay, so the idea is we make a guess, we find a tangent line, we find where the tangent line crosses the x-axis, and then it gives us a better guess. And we keep doing this, and what happens is we start to zoom in to the root. And look, I've only, how many tangent lines have I drawn here? 1, 2, 3. Only 3 tangent lines, and you can see I'm very close to the answer. So after just 3 steps, I've gotten very close to the answer. And if I was guessing, you know, 0, 0, minus 1, 1, minus 2, 2, minus 3, 3, you know, it could take a long time. But the great thing with this is it gets to the answer pretty quickly, So what we want to do now is, with this idea in mind, is try to find the formula to get us closer and closer to the answer. Okay, so are we all clear about the idea here? Yes, we understand the idea? Okay, so let's try and look at a formula. So I need to go to a new page for this. Yeah? Okay, go ahead, yeah. Well, maybe I'll add a little note to the end here. So what we do first is we guess at what the root could be. So maybe we try x0 as the root. Okay, so we call the first guess we make x0. Then we calculate f of x0. Now, if f of x0 is equal to 0, we're done. We found the root. If it's not 0, we're not done, and we have to continue. If it is 0, we are done. We found the root. If not, which is usually the case unless you're very lucky at your guessing, we need to find a better guess at the root, and we'll call it x1. Okay, so I just want to make sure you understand the letters here. x0 is our first guess. x1 is our next guess. And we want to find a formula that takes you from x0 to x1. Okay? Think about it in semester 1. What was our formula for going from x0 to x1? It was very simple. Oh, we will have to find the derivative, but I'm just talking back in semester 1. The formula was +1. For example, if I try x is 2, if 2 is the root, I'm done. If it's not the root, what do I try next? 3. And then if 3 is not the root, what do I try next? 4. So in semester 1, our formula was just the simple x1 equals x0 plus 1. That's what we had in semester 1. Very simple formula to get to the next guess, but it wasn't good. So now we'll try to find a better formula. So can I start now the proof of the formula? Yes. Yep, okay. So we'll need to go to a new page. Well, you'll have to catch the notes up later. I need to go on. 1 second. All right. Wait, there you go. Have some people seen Newton-Raphson before? Maybe you have a different name for it, but no?
I don't make that reference. Either I know how to do it or don't.
Alright, okay. Alright, we'll have a look now at the formula, at the technique. Okay. And I'll need an equation now. Okay, so let's pretend we tried x0 and we didn't get the root, So we have the point x0, f of x0. So this is a point on our curve. Okay, and if we go back to the graph, let's say that was x0, then this point here would be x0 for x, and what would y be? F of x0. Okay, so that's one point on the graph. I want to find the tangent line at this point. I want to find the tangent line at this point. So firstly, what's the equation of a tangent line? Y equals mx plus c. Okay? So I'm looking for the tangent line. So I'm looking for y equals mx plus c. So let's try and find that. Okay. Firstly, the m. What is the m, or the slope of a tangent line? The derivative. So y equals the derivative. You see there? I know that the slope is the derivative. And we've done this in semester 1, so that's no problem there. What do I need to find next? What do I need next? I need the c, yeah? Yeah. Now how do I find the c? By a single point. And I only have one point. What's my point? There it is there. Okay, so now I'll try to find the c. So what is y? F of x0. And what is x? x0. So I have the c. The c is there. There is the c. That looks a little ugly. Let me put it on the left. Okay. Happy now? I found the c. So what do I do next? I just substitute it back in. So let me grab my second line, and now I know what the c is, so let me put in what the c is. There you go. There is the equation of the tangent line. Okay?
For the second line, what did you do?
For which do you mean? This second line? Oh, the m was just replaced by the derivative, because for a tangent line, the derivative is the slope.
The derivative of what?
The function, the f. Yeah? And so you see here, this is the equation of the tangent line.
Yeah, the fourth line, like the c, how did you get the c?
On the fourth line. Well, you see on the third line, I just took this piece here over to the left.
And where is the y?
The y was replaced by f of x0. Because like you said, to find the c you need to use a single point.
Yeah.
So I replaced the x and the y. And here's the x and the y here. So I replaced this and this into line number 2. So the x got replaced by x0, and the y got replaced by f of x0. Yep? Okay. So this here is my tangent line. Now, when I have my tangent line, what point do I use on my tangent line as my next guess? What do I do with my tangent line? Remember, I take my point, I draw it up to the curve, I find the tangent line, and then once I have the tangent line, what's next? Bring it down to the x-axis. So I need to find the root of what? Of the tangent line. I bring it down to the x-axis. So I need to find the root of the tangent line. So in this equation here, how do I find the root of this last line here? What do I do? How do I find the root of anything where it crosses the x-axis? Yeah? Y equals 0. Yeah? So I just replace y now with 0. And then I solve for x. Well, I only have one x here. Do you see it? Everything else is x0. And x0 is actually a number, my first guess. It's not a variable, okay? So I just take these two pieces here over to the left. Sorry, these two pieces here over to the left, and I need to change the sign of them. So that becomes a minus there, and then that one there becomes a plus. Yep. And here, let me put in the line about me making y0 as well. Okay. One thing left to do. What do I do next? Divide by what? The derivative there. Okay. So now dividing by the derivative here. And I have the x. And this here represents where the tangent line does what? Crosses the x-axis. And this is my improvement. This is my next guess. So actually, what is it called? It's not called x. What letter did I say to call my next guess? x1. So I've just found my formula for x1. Now I'm going to tidy up the formula a little bit. So I think I can just about squeeze it in. Let me put the x1 on the left to make it look a little nicer. Okay. There we go, that's better. Now I'll also put the minus f part, I'll put that at the back rather than at the front. Okay, so now it looks more presentable. Now, what I'll do is I'll take this piece here and divide it by f derivative, and then I'll take this piece here and divide it by f derivative. So in other words, I'll split it up into two parts. Okay, so the first one here, I'll make it into two fractions. So the first one would be f derivative x0 times x0 over f derivative x0. And then the second one would be f x0 over f derivative x0. Okay. So I've just split my fraction up into two. Now what happens with the first fraction? Yeah, I can cancel those two there. So let me take that out. Like, have I got space for one more line? I think so. Yeah, there we go. And that is it. That is the nice simplified Newton-Raphson formula. Okay, so that's really key here. So make sure you write this down. I want to show you how to use it next. Okay, do you have this taken down? Yes? This key formula down here. I'll write it again actually. I think it's important enough to get its own box maybe. Maybe even its own definition box. If x0 represents a guess at what the root of fx is, and if x1 represents the improved estimation, estimation is spelled completely wrong, improved estimation, then let's see. I can have this formula here. x1 equals x0 minus fraction f x0 over f derivative x0 like this. So if x0 represents a guess of what the root of fx is and x1 represents the improved estimation, then the following formula gives you the Newton-Raphson improvement on what the root is. So that's, in other words, the x1. Okay. So there you go. That's the Newton-Raphson formula. x1, the improved estimation of the root, is equal to x0, your estimation of the root, minus fx0 over f derivative x0. Okay, so please make note of that, it's very important. Okay, can I go on to an example? You need to, yeah. Actually, while this is up here, I should just make note. What's one problem that I can see just looking at the formula? What's one difficulty that could come about? Well, look, you're dividing by f derivative. Can you divide by 0? No, so I can see at least one case when this formula doesn't work. When is it? When the first guess is making the derivative 0. So in other words, my first guess can't be the maximum or minimum point on the curve. So it would have to be very bad luck if your first guess is actually this. Okay? So I'll just say here, where f derivative x0 is not equal to 0. You don't want that. That's a problem. Okay. And then, of course, when is another case that this formula would fail? Well, it would also fail if there isn't any root. You know, you can't ask a formula to give you the root if there is no root. Okay? But that's kind of an obvious case, I think. This one here maybe is not so obvious. So if you have that taken down, I'll give you an example. Just the other thing to say, you can write this formula in different ways. What some people write is like this, which I think is quite common. They write it as, do you remember the name of when you write a sequence like this from semester 1? Recursive sequence. So they write the formula as a recursive sequence. In other words, the next term in the sequence equals the present term in the sequence minus f the present term over f derivative the present term. Okay, and this is usually how it's written in the book. So if xn represents a guess at the root, and then xn plus 1 is the improvement, then we can have this. Okay. I don't really mind either way which you use. It's not so important. The key thing here is the formula. Okay. Right, we'll have a look at an example now. So what I'll do is I'll look at an example where we already know the answer, and that way we can see how good the method is. Okay. Find the root of fx. Let's pick a nice easy example. Okay, I know. Example 1. Fx equal to x squared minus 4. All right. Now, I don't need any formula here. I know what the root is this. Well, what is the root of this? Yeah, 2 and minus 2. So I know what the possible answer could be. So let's pretend we did know the answer, and let's see how the formula works. Okay? So, firstly, we have to find the formula. So what do we need to know for the formula? We need to know what the function is, and we need to know what else? The derivative. Okay. So the derivative here, yeah, derivative of x equals 2x. So nice and straightforward. And now I can use the formula. So let me just copy the formula in. So there is the formula, and now I start replacing. So fx, that is x squared minus 4, and then the derivative is 2x. So if you want, actually, I'll put both together for you.
Just need to take off the ends.
No, well, I don't mind too much if you leave out the ends, but really, to be correct, you should leave the ends in, because you're saying you were saying that you're using your first guess. So it's not the x variable, it's xn, which is your first guess, or your current guess. Okay. And actually, to prevent any sign mistakes, I'll just put brackets around that because it's minus the whole fraction. Okay, so that will come up now. So I don't want any mistakes with the signs. Okay, let's try this formula. Let's see what happens. So let's pretend I just make a random guess. Let's say I try x is 0. So my first guess is x is 0. So x 0 equals 0. That's my first guess. Is this a good guess? Not great. It's okay. Let's find out what the improved guess would be. x1. So I need to use my formula. So let me copy my formula and replace x with 0. So 0, oops, 0, and 0, and I've chosen a bad first guess because what's wrong? I'm dividing by 0, so I can't do this. So that's a good example of a bad first guess. So let's try 1. So I replace x with 1. So 1, 1, and 1. Okay, so my first guess is 1, and then I calculate my next guess using this formula. Okay, so 1 squared is 1 minus 4 minus 3 minus 3 over 2. Yeah, minus 3 over 2, which is minus 1.5, but there's a minus in the front. So plus 1.5, 1 plus 1.5, 2.5. Now look at that. I've only used the formula once, and you've seen that it's already gotten me pretty close to the answer. You see? Let's use the formula one more time. Okay, so my guess is 2.5, and let's try, whoops, the next guess. So you'll need your calculator out for this, please. Next guess will be replacing 2.5 in the formula.
So it's x1?
Well, yeah, if you want to call it x1, but really, since I've already used x1, I'm going to call the next guess x2, and then, you know, like keep increasing it. I'll explain a bit better now in a second.
Sorry, Stephen, like the 0 doesn't work because is it a root?
Yeah, no. The 0 doesn't work because what happens is, you see in the formula, you're dividing by f derivative. And you can't divide by 0. So the problem is, the 0 actually is a minimum point on the curve. I can't use minimum or maximums as my guesses. So this was bad choice by me as my first guess. I could have picked any other number in the world. It would have worked fine. I picked the one wrong number. Okay. Yeah, just to explain, Jojo, with the notation, okay? x0 is my first guess. x1 is my improved guess. And then what I can do is I can start again and say x1 is my guess, and then x2 is my improved guess. Okay? So can you calculate this please out on your calculator and tell me what you get? Oh, come on, you've got a calculator there. Can you calculate please? Well, yeah. You do have, okay. Right, okay, look, 2.5 squared, that's 5 over 2 squared. That's 25 over 4. 25 over 4 minus 4. So 25 over 4 minus 16 over 4. What's that? 9 over 4. 9 over 4 over 5, because it's 2 times 2.5. So that's 9 over 20. So 5 over 2 minus 9 over 20. So 5 over 2. Huh? 2 point, thank you. Now, wouldn't you say that's pretty close to the answer? Almost there, yeah. And how many times have I used the formula? Only twice. Only twice, and I've almost gotten the answer. Okay, so I want you to appreciate how useful this formula is at finding the root. Okay? Now, there's one other thing I want to show you. The other thing is, you need to make sure that there is a root before you begin. Okay? And the way we do that, I'll just show you. Clear? Graph, curve. Okay, suppose I was to pick this point here. Hey, I was to pick this point here. The f of this point, would it be positive or negative? Be positive, okay? And then suppose I was to pick this point here. Be negative. So if I was to pick this, it'd be positive. And if I was to pick this, be negative. And notice that there's a root in between the two. Now, of course, this makes sense. Like, I mean, if I start at the left and my f is positive, and then I move and my f goes negative, then what must have happened? I must have crossed the x-axis in between. So this is a very simple way to check if there is a root between two numbers. You need to check that the function goes from positive to negative or negative to positive. So let's just try that with this example here. So first, let's check if we have a root. So let me try something like f of 0. What does f of 0 equal in this example here? It will equal 1 squared minus 4, so it'll, 0 squared minus 4, so it'll equal minus 4. Okay? Now, let's check f, I don't know, 10, something like this. So 10 squared, 100 minus 4, 96. Since f went from negative to positive between 4 and 96, we know we have a root between 4 and, sorry, not 4 and 96. That's the, well, yeah, it went minus 4 to 96. So we know we have a root between 0 and 10. Okay, so I chose 0 and the function is negative. I chose 10 and the function is positive. So it means across the x-axis somewhere between 0 and 10. So I know I have a root between 0 and 10. So often what you do with Newton-Raphson is you start at either the 0 or at the 10 and let the formula bring you into the center where there's a root. How do I know what?
Like here, for example, you left with 2.05.
Yeah. Oh, how do I know I'm close to the root? Yeah. Like, how do I know I should stop? Yeah, the way you know you should stop is if the changes start to get smaller. Okay, so if I was to calculate the next term would probably be something like 2.005. So it makes me think, oh, I must be getting close to the root because the formula is not really making me move anymore. You know, so usually it's when it stops moving so much. It means, oh, you must be near the root because there's no need to move anymore. You know, But in the exam, don't worry about this. In the exam, they will tell you very directly, use the formula twice to help you estimate the root. So you don't have to worry about this in the exam so much. But usually, usually you only need like 2, 3, 4, 5 at most uses of the formula to get you to the root. Okay? Now what I want you to do before we finish is I want you to try at least one of these in the workbook. Okay? And just before we finish this here, I just said there's some cases whereby this formula doesn't work. 2 obvious cases. The first obvious case of when it doesn't work? Yeah, the formula doesn't work if it doesn't have any roots. Can you give me an example of a function that doesn't have any roots, any real roots? I could have said x squared plus 4. Because x squared plus 4, what's the root of this? It would be square root of negative 2, square root of negative 4. So this doesn't have any roots, okay? And then the other case where it doesn't work, I actually showed you accidentally, is if you choose a point that makes the derivative 0, doesn't work. Yeah? So are we clear of the cases when it doesn't work? Yeah? And you understand how to use the formula? Okay. Just very briefly, just to say, can you just look here real quick? Whoops. Let's say I ask you to solve this. Oh, I don't know. Something like this. Suppose I ask you to solve this equation. Can you use Newton-Raphson on this? Well, at first you might think no, because I'm not looking for a root, But I could just make one very simple change to this. What would that be? No? If I just take this x over to the left, look at the equation now. I have ex minus x equal 0. So now I'm looking for the root. And in this case, what's the function? What's f of x? F of x is what? Ex minus x. Okay, so just it's worth mentioning that sometimes they ask you to solve an equation and they're not actually asking you for the root. But if you just make a very simple change, you could make it into a problem whereby you're trying to find the root. And this is important again for the exam, because I've seen this in the exam where they say something like, oh, ex equals x, solve for x. So you have to first prepare the equation, okay? What's another way I could have done this? Well, I could have taken the ex over to the left and written it like this. So what's the function here? X minus ex. Same function or different function? Different function. Same answer or different answer? Same answer, yeah. So there's a couple of ways to look at it, okay? So I just want you to appreciate that. Yep. Okay, so I want you to try questions in the book. Now, a good one to try would be something like 5-1. 5-1. I want you to try this now. Use your calculator. They tell you actually what to take as your first guess. Oh, and by the way, look at the book. What letter did I call the first guess? X1. What did I call it? X0. It doesn't really matter, okay? You can start at 0, you can start at 1. It's just a choice.